So today in this video we're going to learn how to sketch a curve. For that we should have to follow few steps. The first step is that we have to find the y-intercept and x-intercept. In case of y you have to put x is equal to 0 and in case of x you have to put y is equal to 0. For example, here is the equation and we have to find x and y-intercept. To find the y-intercept we put x is equal to 0. So we get y is equal to 4 upon 0 minus 1. It means you get y is equal to minus 4. So the point is 0 minus 4. And for x-intercept we put y is equal to 0. So when y is equal to 0 the whole equation will become 0. It means x is also 0. So we get the point 0, 0. We have to underline this point. We mark this point on the graph. We have point here. Second step is to find the vertical asymptote. For vertical asymptote, we have to put the denominator equal to 0 and then find the values of x. And also in this case, you can find the or determine the behavior by putting the left and right hand side limits. For example, you can see in this equation, the denominator is x square minus 1. We put equal to 0. So we get x is equal to 1. X square is equal to 1 and the square comes, it becomes plus minus 1. So vertical asymptotes are plus minus 1. We can underline it on the graph. Here are the vertical asymptotes. Okay, now the third step is to find the horizontal asymptotes. There are the three conditions that you should memorize. If the numerator is less than denominator, then the horizontal asymptote is 0. For example, let's suppose it's x square and it is x raised to power 3. So the numerator is 2, denominator is 3, it means y will be 0 here. No horizontal asymptote will be there. And third case is if the degree of denominator and the degree of numerator both are equal. Let's suppose it's x is to power 2 and 3x is to power 2 and x is to power 2. Both numerator and denominator are same. So in this case, you have the result. Horizontal asymptotes are the ratios of the coefficient of highest term. The highest term is x is to power square. So the y is 3 upon 1 ratio of coefficient of highest term. This it will be. The third is if the degree of denominator is equal to degree of denominator plus 1. So in that case, you have to divide the quotient of px to the qx. Let's suppose we have an equation something like x cube upon x square minus 1. So in this case, you can see the degree of denominator, which is 3, and it is equal to the denominator key 2 plus 1. It means it is following this third part. So in this case, this is, you can assume this is at qx and this is at px. So you need to divide px by qx, and in this case you have to divide x square minus 1 from x is to power 3 and you will get the oblique asymptote here in this equation. We will do these type of questions also. So let's see the question we are doing. In this question, the next step is to find the horizontal asymptote. For that, you have to check the degree. In this case, denominator is nothing. There is x power 0 and it is x raised to power 2. It means denominator is less than denominator. It means there will be no horizontal asymptote in this equation. Step is to find the first derivative, and whenever we're gonna find the first derivative, we can first have to find the critical points by putting the f dash x is equal to 0. Then you will get the critical numbers at that point, and you can also find the local maxima and minima point. If the function is sign is increasing or decreasing, you can analyze it from there. And if f dash x is undefined, it means there will be a vertical tangent. And if also you can find that if f dash x is increasing, it means it is an increasing function, and if f dash x is less than 0, it means it is a decreasing function. We can analyze it on a given equation. First derivative, I am taking this upward. 4x square minus 1 raised to power minus 1 is coming upward. So first derivative, 4 minus 1 will be there. X square minus 1 minus 1 minus 1. And again 2x. Solving it, further we get 4 2s are 8x minus and x square minus 1 raised to power 2. This is the first derivative. Now we have to put first derivative equal to 0. So we will get minus 8x, x square minus 1 raised to power 2 is equal to 0. Now we get here, you can see that from here x value is 0. And this is, we can also find the value of x, but we know that they are the vertical asymptotes having the value plus minus 1. So the next step is we have to make a number line. doing it on another page. We have to make a number line. We got the values of x 0, 1, minus 1 और एक हमें मिली थी plus 1 and the number line is from minus infinity to plus infinity. Now we at each point we have to check whether the function is increasing or decreasing. We get the first derivative minus 8x x square minus 1 का whole square. So let's take any number between minus 1 to minus infinity to minus 1. Let's suppose I take a number minus 2. Put value of x minus 2 in this equation and check whether the function is coming positive or negative. Like I am checking at minus 2. So minus 8 minus 2 again minus 2 ka whole square minus 1 ka whole square. Definitely 8 to the 16, so it's coming in positive, right? So it means function is increasing there. Again you need to find in between minus 1 to 0. Take any number in between them. You can take a minus 0.5 or any other number. So again, if you take a 0.5, let's suppose minus 0.5, so you will get something positive. Put the value of x to it yourself. Now take any number in between 0 to 1, like take plus 0.5. So when you will take, here function is increasing. Now take plus 0.5. So it will be minus 8 into 0.5, 0.5 ka whole square minus 1 ka whole square. So it will be coming out to be negative. From here you can see it's coming negative. The function is decreasing here. Now take any number in between 1 to plus infinity. Let's take number 2. Again it will become negative. It means the function is decreasing here. Right? Now just you have to check at point that you get the point x is equal to 0 now. So at x is equal to 0, you get point x is equal to 0 here. So if you will put the at this point, you will get the y value for minus 4. You have also calculated this at this point. So the point is 0 by minus 4. It means the function is increasing positive. It is increasing first and then it is going to decrease. And whenever there is unsmile, not smiles, sad face. And a sad face, it means it's local maxima. So it means this point is nothing but this is local maxima point. And you can also draw it minus 1 to plus 1. है ना, यहाँ के बीच में it will be down. So you get this point, making it from another color. So you get this from the first derivative. Got this? The last step is to find the second derivative, and in second derivative first you have to take a second derivative and put it equal to 0, and that point you will get the point of inflations if the sign is changing, and if it is greater than 0 it is a concave up sign, something like this, and if f double dash x is less than 0 it is concave downward. And the upper one is also called local minima, and this is also called local maxima. If it is sad, it is local maxima. If it is smiling, it is local minima. So let's do it in our equation. So I have taken the second derivative here. You can see second derivative. Now the next step is to put the second derivative equal to 0. So putting it equal to 0, we have to find the value of x. So this is equal to 0, and here you will get the value of x is x square is equal to minus 1 by 3. So you know that x is equal to root of minus 1 by 3. Root is never under, the negative is never under the root. It means there will be no inflation point. You get no value of x there. So there will be no point of inflations. And the next step, you have to find where there will be concave up and where there will be concave down. For that, you have, in case of second derivative, like in this point, you have to check. You have to make a number line first. And the number lines goes from minus infinity to plus infinity, and only the 2 points from here or from the vertical asymptotes also you get the value of x as minus 1 and 1. So you have to check in between this and this whether the function is concave up or concave down. For that, you have to take the first derivative. You can take any number in between minus 1 to minus infinity. Let's suppose take a number minus 2. Now put the in place of x, put the minus 2 and check whether it's coming positive or negative. So 2, it will come 2 to the 4 minus 1. So it's coming positive. Positive means it's concave up. It is coming positive. It means concave up. Now check in between this. Take any number. Let's suppose take a number 0. And check f at 0, check it coming 0, you will get it will become 0, and here it will be minus 1 raised to power 3. Definitely it is negative. Negative means it is concave down. Now take any number in between 1 to infinity plus infinity. Let's suppose take a number positive 2 and check. So again same, it's coming concave up. So here it is coming concave up, here concave down, here concave up है ना. यहाँ पे up रहेगा, यहाँ पे down, there will be up. So you have to plot this on the graph. So from minus 1 to infinity है ना, from this point there is concave up. So the up will be like this. It will be something like taking another color, it will be something like this. And it doesn't have a particular point where it is, that's why it's going beyond like this. And also from a plus 1 to infinity there is also concave up. It means it will be up. I'm drawing this. Okay, this will be the final graph and the result, how you have to sketch the curve. I hope this is clear to you. If you like the video, please don't forget to subscribe and like the channel, and please share it with your friends if you are getting it. And you're having any problem in any other step, any of the step, you can ask me on the comment section. Definitely I will help you on each and every steps. Okay, bye bye.